We'll see how this works.
All right, so just put the rod off to the side for just a moment. All right. Please don't let go. All right, so basically I'm gonna send a wave down to her. Hold that still. And so first off, the question is, what happens when the wave hits the boundary?
Turns back.
All right, anyone else observe how it comes back?
It
The
flipped over.
structure.
It flipped over.
Yeah, it flips over. So it reflects but inverts. Put the rod in so that it's going this way. No. No.
Oh.
All right, thank you. So now, when I send the wave down, think about how it comes back. That was. What did you observe? All right, let's try that one again.
It shifts up, not up, but to the right.
Yeah, and it's just, if it's doing the same motion that I'm doing, I go this way and it goes that way. So the reflection is on the same side. So this is known as a free end, and the other one was a fixed end. So on a fixed end, the wave will flip sides, and on a free end, it stays on the same side. All right, go ahead and take the rod out. I think we're done with that. All right, so now we're gonna send a wave down. I think we're pretty much on this line right here. So we're gonna, on 1, 2, 3, go, and then we're both gonna come out to here.
Okay.
1, 2, 3, go.
Go out and come back in?
Yeah.
Okay.
Good. Thank you. Okay, 1, 2, 3, go. What happens when the waves meet?
They cancel each other out.
Say it again?
They cancel each other out. And kind of met back in the middle.
Let's check that out. 1, 2, 3, go. Did they cancel each other out?
It's more like they bounce off of each other.
So they met in the middle and then they inverted and went back the other way. So it's like they hit the fixed end, they reflected and went back the other way.
I did not observe that. Let's check that out again. All right, so 1, 2, 3, go.
It shot that way when it came back.
It did. The more interested in when they met. They actually don't bounce off each other, they go through each other. But what about, how far did Elizabeth Ann take her hand? What was the amplitude of the waves she created?
It would be whatever the distance is from where her hand is there to the end of that line that she's stopping at.
Okay, and these are, what, about a foot, 1 by 1s? So the amplitude of hers was about a foot, mine also should have been about the same. When they met, what was the amplitude? Let's do it again. Okay, this is the line right here, I don't know if you can see it from where you are, but, all right, 1, 2, 3, go.
It's less amplitude after they meet.
Say it again.
Smaller amplitude after they meet.
Smaller amplitude.
Wait,
How far out does it go this way?
like it starts to shake less.
1, 2, 3, go.
It goes past it.
It does go past it. One more time. 1, 2, 3, go.
Is it double?
In theory, there is some loss because it's dragging against the ground, but yeah, if there were no dragging against the ground, it would be double. So it does go past this line right here. Neither of our hands go past this line, but the slinky or the coil did. One more time. 1, 2, 3, go. Constructive interference. Because the combination was bigger than either of the individual waves. All right, now let's go opposite sides. I'll go this side, you go that side. Okay, 1, 2, 3, go. So in the middle, when they met,
They flip-flop. Like, when it was coming this, yours was coming this way, yeah, when yours was coming this way, it shot this way after, and then when I shot this way, it went that way on your side.
okay. Like they bounced off each other and flipped?
Yeah.
Actually, they passed through each other. So yours stayed on this side, mine stayed on that side. All right, 1, 2, 3, go. But in the middle, it doesn't move anywhere near as much as it did before. So let's both go to this side. 1, 2, 3, go. And now opposite sides. 1, 2, 3, go. Destructive interference in the middle. All right, just hold yours still. I'm gonna send a wave down to have it reflect. Fixed in, when it hits, it should flip over. If I send a second wave, my second wave is gonna interfere with the reflection of the first wave. If I do it correctly, we should start seeing patterns. All right, we got this point in the middle, which isn't moving a whole lot. We have these points here and over there, which is moving a great deal. The points where it's not moving, or in this case, not moving much, ideally not moving at all, those are called nodes. And there were 3 nodes there, in theory. There was the node where Ellie's hands were, there was a node in the middle, and then, in theory, a node over here. See if we can create that again. Now this is known as the second harmonic. Notice we got these, we have in the middle at the node where there's destructive interference the entire time, and then we have these points here which is going back and forth between constructive and destructive. Because my hand is not going past these lines here, but the coil is. Now the simplest of these patterns with 2 fixed ends would be called the first harmonic. And this one's not particularly easy to do, but first harmonic, that's the simplest pattern. This one here, second harmonic. So I increase the frequency. Is that 3 nodes, 3 antinodes? 3 antinodes would be the third harmonic. See if I can get a fourth one here. It's either 4 or 5.
5.
That's a fifth harmonic. Couldn't quite get the fourth one. All right. So we got these standing, they're called standing waves. I've got sending a wave down there, it's reflecting. I send another wave, it reflects, and so forth. And so we get these patterns of it's interfering with itself. I'm now going to tighten it. What do you think this is going to do to the wave?
It'll shrink it just a little bit. The amplitude will shrink.
Why?
That's a great question.
It might in the reality of this. Ideally, it would not, but that's not the thing to be affected, but it might. Let's see, so if I just did that. That's a second harmonic there. Is that a smaller? It is, I heard it, yeah, it is smaller. And other people said no.
It looks
What's happening as I tighten it or loosen it? What's the difference? tighten.
The weight is moving faster.
If you think about it, these are transverse waves we're creating. As this moves out this way, it pulls the next one with it. And that pulling force between the coils is tension. So as I increase the tension, as I pull this closer to me, I increase the tension, which means that each coil is pulling that much harder on the next coil. So it's going to react much faster. So we do get a faster wave. Or in fact, even more.
It also seems to travel further, although that might just be you can see it visibly for longer.
I think it's because the friction acting on it is acting for a certain amount of time. So impulse, and since it's moving faster, it might still be dying in the same amount of time as before, but because it's moving faster, it just goes farther. All right, so I've done the harmonics there. More to go in, just make sure there's nothing else. Yep. We'll settle it there. Thank you very much. Let's head back into the classroom. Ow.